All right, well, certainly it's a pleasure to be back here in Atlanta. I want to talk about Scala today. I'll talk about some of the features this language offers. Best time to ask a question or have a comment is when you have it, so please don't wait till the end. If you have a question, just raise your hands or start speaking so I know you're asking a question. So let's talk about Scala. We've been working with Java for quite a long time, and right about 2003 timeframe, we started seeing other languages moving on to the Java virtual machine. And why should we be excited about some of these? And notably today we'll talk about Scala. So the question I would first start out with is why Scala? Why should we look at a language like Scala? And so Scala, the reason simply is that when we write code, we are trying to implement a certain idea that we want to get across. And when we are trying to implement it, we want to write as little code as we possibly can to get our work done. And so in terms of expressiveness, Scala is a very highly expressive language, meaning we're going to write a lot less code, it's very concise. And as a result, it is very powerful to get a concept out. And it is also an object-oriented language. It's fully object-oriented, a lot more object-oriented than Java is if you look into it deeper. And it's also a functional language, but it's actually a hybrid functional language. And what that means is a pure functional language will impose a certain style and immutability, whereas Scala doesn't do that. Scala kind of gives us the flexibility, and we can kind of change this knob all the way to the left or to the right and say, I want this to be fully object-oriented versus I want this to be more imperative versus functional style on the other hand. So what is Scala? Scala is object-oriented, hybrid functional language running on the top of Java virtual machine. We can write any code on it that we would otherwise write in Java, but with a lot more conciseness. We're looking at about roughly about 50 to 60% reduction in code size. What that means is we are able to write a lot less code to get our work done. Now, of course, there is a cost to this, right? And the cost is you've got to learn a different language, and that takes effort, right? Now, remember the time, I know this is hard for a lot of us to do, but remember the time when you didn't know Java, right? But you had to pick up and learn Java. But to a lot of extent, that was not too difficult if you came from the world of C++, because most of language syntax in Java was C++ syntax. And in fact, to a great extent, Java was kind of C++ minus minus, right? They kind of removed a few features from C++ that kind of was notorious, and they said, we'll make it easier. And then they threw in automatic garbage collection into it, so that made our life a little easier. Well, with Java, you will have a little bit of familiarity with syntax, but then soon you will start deviating. And the reason is, it is not the syntactual difference that you're going to face, it is the difference in the concept and the paradigm, which is the functional style of programming. But the good news is that's going to be the case even in Java 8. So when you get used to Java 8, you're going to kind of going through the similar approach and changing the way you write code. So that's kind of something we need to look at. So let's talk about this with some examples. What about functional style? What does that feel like? Now, let's look at an example and see how we would implement a certain code and how we would work with it. Let's say for a minute, we have a bunch of numbers on our hand. And I want to say these numbers, let's start with a list of numbers. Let's kind of throw in a few numbers. Let's say 6 numbers here. And I want to be able to total these numbers together. Now, how would you total this in Java, for example? Well, in Java, we are pretty much used to the so-called the imperative style of programming. And imperative style is kind of orthogonal to object-oriented style. In other words, we kind of use them together. And in an imperative style, there are two distinctive things we notice. One is we tell it every step of the way what to do. For example, create a variable, start a loop, step to the next variable, next iteration, go ahead and pick this value, total this to this. So you're kind of giving them a detailed instruction in terms of what to do. That's imperative. The second sign of imperative code is when you take a look at the code, you clearly see mutability happening all over. So for example, I'm going to say total equals 0, and I want to print this total value. So I'm going to say total is, and I can simply say the value is total. So this is basically going to print the value of 0 in this case, right? Because the total is simply created and its value is 0 at this point. Well, there's a little improvement in style in Scala. So we could also say, for example, a total like this. And of course, that simply says, I don't want to be using plus to concatenate, values. Just use this value to print it. So this is a specialized string that you're using to print its value. But the point really is, we want to be able to total, but how do we go about doing this total? So let's think about Java for a minute, and then we'll come back to Scala, right? So pretend that we are in Java for a minute. How do you write a loop in Java? Well, for I, or int I equals 0, I less than, and that's when your brain pauses for a second, right? Because you got to throw this exception on yourselves. Is it less than or equal to? How many of you have done that, right? All of us. How many of you want to go back and do that more? Nobody, right? Because that structure is called self-inflicted wound, right? There is no reason to inflict that on ourselves, right? It's got to be much easier than that. Well, thankfully, Java did that, right? Java said, hey, why don't we say for int number, let's say number in nums, right? That's the way you would write it in Java. Now, of course, we don't use the word in because that would conflict with a keyword if it became a keyword. Say they used a colon. But this is exactly an external iterator. But we can still do that in Scala, for example. So we could say, for example, for, and what do I want here? I want a number, let's call it num, in what nums. So we're kind of feeding this variable num with this value nums. And as we loop through this value, I'm going to simply say total plus equals the value of number, and we're just totaling these numbers together. So this is an imperative style of coding, and we're used to this. So I didn't do anything different here in Scala than we are used to in Java. Throw in a few semicolons around, put a little bit more type information, we got a Java code, right? But this is imperative because we created a variable, told him every step what to do, and totally mutated this over and over and over. So that is what makes this imperative style. Now, in a functional style, we wouldn't go through this kind of effort in doing stuff. So for example, what I'm going to do here is to say, I want to simply say total value. So one more time, I'm going to say total s. But what is the total? I'm going to say, let's say total 1. So I want to print out this value called total 1. But where is total 1? I'm going to create a total 1 as a variable here. But this one is going to start out with nums. And I'm going to use an internal iterator rather than using an external iterator. An external iterator is where you tell him every step of the way what to iterate. Go to the next element, go to the next element. Even when you use the for each in Java, it's a little syntax sugar over the iterator itself, right? Has next, and has more and next, and you keep calling it. In the case of internal iterator, you kind of put him on an autopilot, and you say, you go off, you know where to go. Right? And he's on his autopilot. And you tell him, here is the logic I want you to perform for each of the elements in the collection. So rather than keeping your eyes focused on the iteration, you put the iteration on autopilot and focus on what you want to accomplish per iteration, and then he kind of collectively does that for you. So in this case, I'm going to say fold left is the method we're going to call. And fold left simply says, I'm going to take elements and apply this through a series of these elements. Start with the initial value of 0. And what am I going to do with this value? So I'm going to get a carryover and a current element. And I want to return a current element plus the carryover. And that's the total I want to perform. So you can see that that code really performed the task. But that looks very concise. But if you're not used to the syntax, that's going to feel intimidating, right? We're going to look at this and say, gosh, that's so ridiculous, it's hard to understand. But we have to take the time to learn the language before we can benefit from it, right? It's kind of like, if you've never driven a car, and you look at a car and say, gosh, who would ever sit on this? Because it looks complex. But of course, you will never get the benefit of using a car if you never sit in a car and learn to drive, right? So that's where the courage comes in to kind of sit down and practice that. So what does this say here? Well, let's think about this with a slightly different example. Now, how do you really total values without mutating anything? And that seems like that's ridiculous, you cannot do that. But let's solve the problem with a slightly, with an example. Let's say I want to total the age of everybody in this room. And we will do that starting with him. He's just turned grim. No, I'm not going to ask for your real age, right? So, but here's how we're going to do this. I have a bunch of post-it notes, but these are specialized post-it notes. These are write once post-it notes. They are immutable. You cannot erase what you write on them. You cannot change what you write on them. You cannot overwrite on them. They are write once post-it notes, right? So on the first post-it note I have with me, and I got a lot of them with me, I put a 0 on it, because 0 is the age of everybody I know so far. And I give it to you. And what's your name, sir?
Rich.
Rich. I give it to Rich. And what's Rich going to do? Rich takes the 0 given to him, totals his own age to it, but obviously he can write on the post-it note. So what's his option? Create another one, right? So he tears up another post-it note, puts his age on it, plus the 0, and then passes it down to your name, sir?
Glenn.
Glenn. So passes it down to Glenn. So what does Glenn do? Glenn takes the number given to him, adds his own age to that number, and passes it down to
Lee.
Lee. Yeah. Right? You see how this is going, right? And what does Lee do? Totals his age to the number, writes it on a post-it note, and passes it down. And eventually, what I get from the person in the last row here would be the total of everybody's age in this room. But what happened in this process? Not a single post-it note was mutated. We didn't ever change anything, right? We only created new stuff along the way. So total immutability in this case. This is, if you understand how that works, that's exactly what I did here in the code. What I did in the code is, we got a list, and I said, here is your initial value 0, by the way. Start with the 0 post-it note. And we pass to this fold left method 2 parameters. The first parameter is this initial value 0, an object. But the second parameter we pass to him is a function itself. So rather than passing objects to functions, we are passing not only objects but also functions to functions. So the function says, I'm not going to say only give me objects. I'm willing to accept objects and I'm willing to accept functions. In fact, this function raises itself to say, I'm more accommodative. So it is a higher order function, that's why. So a higher order function is a function that will receive functions as parameters as much as receive objects as parameters. So in this case, we send 2 parameters to this function, the 0, which is the first parameter, and the highlighted function itself. Now this highlighted part is a function, but think of this as an anonymous function. But we don't call it as anonymous function, we call it as a lambda expression, or we call it as a function value. And in Scala we call it function value. In functional programming we normally call it as lambda expressions. And so this says, I'm going to pass an anonymous function to you, a lambda expression. But what's a function? Well, for most of us, a function has 4 things, right? A function has a name, a function has a body, a function has a return type, and a function has a list of parameters. Well, in this case, this function has all those 4. Well, what is the well, of course, the most important thing is the body of the function, right? Well, the body of the function is to the right of this arrow. So right after the arrow, up to the end of this, that is the body of the function. So we covered the body of the function right there. What about the parameter list? The parameter list is to the left of the arrow. Well, normally when you write a parameter list, you normally place 2 things. Types of the parameters and also the names of the parameters. Well, in this case, the names of the parameters are C and E, but the types of them, we didn't have to specify it. And the reason is, Scala says, I can infer the type. We didn't have to give him the type. I'll talk more about this a little later. Hey, what about the return type? Well, the return type is inferred. We didn't have to tell him that. He inferred it based on the context. Hey, the last one, of course, the function name. Well, what's in a name? This is an anonymous function. We don't have a name for this function. So we pass this function, but what does it do? Well, Scala first in the for left method calls this function that you gave to him, binds the variable C to the initial value 0 that you provided, and binds the variable E to the very first element in the collection. This is like Rich being given 0 and runs in this context with C as 0, the value given to him, and E as his age. I was going to say current age, but Well, okay, age, right? And then, of course, he produces a result, which is the C plus E. And what does he do? He returns it. And the for left grabs the return value, turns around and calls the function one more time. But this time, C is bound to the previous result, and E is bound to the next element in the collection, right? So this is basically where we are just traversing through the list, running this in the context of each element, where the C is being fed back from the previous call, and E is new element coming into the context. So what we get in the end is a cumulative result of it, and we saw the result of running this code, which is the total of the value. Now let's take a look at another example of this, just to kind of get a feel for how this pattern can be used over and over. Now imagine for a minute, if you are asked to double each of the values in this collection. How would you do this in Java, by the way? Let's think about Java for a second, right? So in Java, you would do something like this, right? So this is Java version. First, you would say list, integer, and you would say, for example, doubled list equals new array list of integer, right? That's the first step you would take. Well, of course, if you're using Java 7, you don't have to say integer twice. That's a bit of an improvement, right? Excellent. And then what would you do after this? You would then say for a number in nums, right? Something like this, nums. And then what would you do here? You would say double the list, dot add, and num times 2. And when you're done with it, you can print out, if you're interested, you could say system.out.println, and then you would print out the doubled list. So look at the sequence of steps we took to double elements in a collection. We first said, go off and create an empty list for me, please. He said, all right, I'm done with creating an empty list. What do you want me to do? Come over here and step to the elements now. And he's stepping through the elements. Then you say, go multiply a value for me. He said, okay, here's the new value for you. Now add it to the list. There's a name for this. It's called primitive obsession, right? We're working at a very low level. How many of you have written code like this in your work? Almost everybody in this room. The ones not raising the hand are in a state of denial, right? Absolutely, we all have written this, right? And how do you feel when you write this code? Dirty. That's how you feel, right? You feel dirty. When you go home, do you feel like upbeat? You go tired, right? And the children come running, you say, don't touch me. I got to shower first, right? And you say, what about people working at home? This is even more dangerous. If the kid runs, running into the room, you have to close the monitor right away. Otherwise, the kid looks at your code and say, that's what you do for a living, right? And they don't want to take up our profession after that, right? This is sad code. We shouldn't be writing code at primitive obsession, right? So how can we do this differently? Well, what we can do here in functional style is we can simply say nums.map. So map is a mapping operation. We are saying, hey, transform this input collection into this output collection. There's nothing to mutate here after all, right? It's a transformation. If signals are coming into your TV, what do? You transform those signals. That's how you use cameras, right? You're transforming. So what are you saying here? You're saying, given an element on my hand, I want to return twice the element. That is all I'm interested in doing, right? So we applied the transformation, and as a result we are saying, given a set of input, I want a set of output. And once you kind of get a hang of this functional style, you could do this in Scala, and very soon you can do this in Java also. Not very different from the syntax you're seeing here, right? Not very different at all, actually. But the concept is the most important thing. If you, oh, please go ahead, yes?
How do you know that to bind that E to the nums list?
How do you know to bind the E to the nums list? Good question. Notice that we are calling the map method on the nums, right?
Okay.
Map is a method, like our method like add and remove on list. Map is a method on this collection. So the map is running in the target in the context of the given list. And the map is receiving the function as a parameter. So it's got two sides to it, right? On his one hand, it's got the collection given to him, which is the nums. On the other hand, he has a function on his hand. And now he says, all right, I've got this function, and I've got a list on my hand. I'm going to take one element at a time from the list, throw it into this function. Whatever the function does, I don't care. But whatever the function is returning, I'm going to collect it. And once I collect all the results back, I'm going to return to you that collection. So all that he does is, the map works on the list given to him and applies this function for E is 1 first, E is 2 second, E is 3 third, and so on. But the key here is, it's a bit misleading when you look at this code. Our imperative mind makes us think that E is being modified every time. Not true at all. E is a brand new variable every time you call this.
So what happens if you pass two variables over there?
What happens if we did in the for left method,
Yeah,
but not in the map method though.
Okay.
In the case of map method, the type checker will be very upset at us.
Okay.
And say, hey you, the map is expecting a function that takes one parameter, but whereas you're giving me something that takes two parameters. It's kind of like the plug, right? You try to plug it into the socket, it fits. But when I travel to Europe, I try to put that, it doesn't work. Because the interface is not matching, right? It's a very similar concept. The type checking comes in to verify that for us.
Okay.
So in this case, if I were to give like a C and a E like I did the last time, we're going to upset the type checker, it barks at us, right? But this is a compile time error, not a runtime error in this case. So it gives us an error right there. Excellent. So we looked at an example of how the functional style is going to work here and what benefit we reap out of it. So, but what about, typing? We didn't specify the type information so far, isn't it? How do we go about specifying the type? Do we need some help over there? Are we okay?
Yeah.
All right. So what about typing? Scala offers static typing. Scala is a statically typed language, but Scala is more statically typed than Java is. So we can't say Scala is statically typed like Java. That's not a good statement. Now let's think about this for a minute. What would we do in Java normally? We would specify the type of almost every variable we declare, right? Well, in the case of Scala, I can say string equals, hello, for example, right? And I want to print the string, so I could say stir. Now, when I started programming in Scala, when I was new to it, I learned that Scala is statically typed. So immediately I said, oh, it's statically typed, I better start putting types. And every time I write code, I would start putting types. And one morning, I realized, wait a minute, I'm doing this wrong. I ran over to the computer, took some code I had in Scala, removed all the type information from it, and ran the code, and the code still worked. And I turned on the volume on the computer, and Scala was finally laughing at me. It said, finally you figured out what this is all about, right? So with a more statically typed language, you actually do less typing with your fingers. Because the language is smart enough to know what the type is. And as a result, notice, I don't have to tell him what the type here is. So right now, as you can see, when I run this, he is quite happy with it. He knows that string, str, is a string. You say, how in the world did he know that? Because we told him that. It's right there, right? In the case of Java, we've been saying the obvious. And we've been kind of saying, it is a string equals a string value. And you're kind of like, why can't he figure it out? Right? Well, now you say, wait a minute, but what if I were to say something like this? If I had defined a string, now I come down to this code and say, let's say this is a variable for a minute, and I say stir equals howdy. So I change the value. I want to print the new value that I gave in this case. Sure, why not? I'm able to print the new value as well. But on the other hand, if I say stir equals 1, I get a compilation error. Right there at compile time, Scala says, you cannot possibly set this to 1 Because you declared the string str as a string, didn't you? Now I remove the str because I wanted it to do type inference. And if I go back and run this, I get exactly the same error because Scala figured out that is a string. And we didn't have to tell him that it's a string because it's pretty darn obvious. So type checking basically is in effect at compile time. If you were to compile this code and take a look at the bytecode, right there is the definition as str is a string type. So what did it do for us? It removed the ceremony for us to be typing the obvious. And you may say, well, okay, if you remove the ceremony, what if I don't mind having it? Well, Stuart Holloway has an interesting blog post. He says ceremony damns us twice. It really makes it hard to write code, and that's where it kind of creeps in. And this reduces the amount of code we have to write. Of course, we got to give good variable names. But even in Java, when we put type information, we better give good variable names, right? We don't want to say int L1, L2, and L3. Nobody knows what that means. Right? That's worse, right? So same thing applies here. We want to give good names for these variables, absolutely. So we are giving these type information, but they are only redundant and we don't have to. So the only time we have to give a type information is only when it's not very obvious or when it's not very clear, it's ambiguous. So usually where we give type information in Scala is when we define functions. And most of the other times we don't have to give it. Great. Now, we have two types of animals in Scala, vals and vars. Let's think about this with an example again. Let's say this is Java. And in Java, we have read effective Java, and what did effective Java say? Make all your variables final as much as you can. So how do you write this? You would say string, some s1 equals hello. Well, we know that s1 is the value of the string is immutable. We know that. You cannot change that string, but you can modify S1. It can point to another string. You cannot change the string object, but you can change the reference, isn't it? But in Java, you would also say final string S2 equals hello. In this case, the object is still immutable, but the reference is also immutable. But one of the problems in Java is you better remember to put this word final. How often do you forget to put final? For me, it's only 100% of the time. Right? When I was writing the Java concurrent, the programming concurrency on the JVM book, I recommended that use final as much as you can. Well, it would be kind of foolish to write a book that says that, and you open up the book and every code in Java doesn't have final, you laugh at me, right? So I wrote the book, and I of course put final wherever I remembered to put it. But before it went out, one afternoon, I simply went through the entire code looking for where I forgot final. That afternoon was the lowest point of writing that book. And when I finished and sent it out, a week or two after the book went out, somebody tweeted saying, oh my God, I'm looking at Venkat's book. He's got 350 finals in the book. I tweeted back to him saying, aha, but you still missed where I forgot to put it. Right? How frustrating it is when you forget to put final, right? And somebody modifies the variable and you're like, darn it, that became a bug, I want to fix it, right? Well, what if the language requires you to make a clear decision? Scala says, stop right there, make a decision now. Do you want this to be a variable or do you want this to be immutable? How do you say that? In Scala, you would write this as var s1 equals hello, meaning this is a variable, var, or you say val s2 equals hello, meaning this is immutable. Now, why is this better? For two reasons this is better. The first reason is it stops you at the gate and says, you make a conscious decision and be expressive. You don't come back to me tomorrow and say, oops, I forgot to put final, can I add it now, please? Right? The second thing is this. You all know how to use grep. You can use grep and find where final appears. Do you know how to use a grep to know where you forgot to put final? That is one heck of a grep. But look at the beauty here. I can quickly write a grep for where you have used a var, because you have used a var. And I can quickly do grep var in the code and say, why is this a var and not a val? It becomes quick for me to do code reviews. I would say make it work, make it better. A huge philosophy I like to follow, right? I would let my guys write code and say, ready for some code review. Grep var. Hey, why is this a var and not a val? And now we can lean towards immutability much more easily than saying, how do I know this? You would say, well, but IDEs can do that. Well, we'll talk about that later. Okay. So, that is the beauty of this. So this brings us to the essence versus ceremony. What does that really mean? Let me give you an example of essence versus ceremony. You are asking me to write a class. All right, let's write a class. Public class car. Private int year. Private, oh sorry, forgot to put final. Private int miles. Public int get year. Oops, get year. What should this do? Return year. Public int get miles. Return miles. Public void set miles. Now here comes the most favorite part for me. You have to declare this as miles also, because there's no other variable in the word. And then you use this dot miles equals miles. I want to stab the guys who write that, right? That is really bad coding, isn't it? Are we done? No, we have to write the constructor. But can we take a break, please? Of course you know what this code is, right? This is Java code. I know what you're thinking. Venkat, this is not fair. We never write this. We declare these variables. And then we gently right-click on it. And before we could blink our eyes, the IDE vomits the rest of the code. So what you're telling me is, not only do we want a complex language, but we want a language that constantly vomits with the IDE. And who is going to live with all that vomit? Right? No, don't point at me. All of us, right? So we have to live with this IDE vomit, right? And you're stepping through the code like this. Right? Don't step on that. We don't want to touch that code, right? It becomes really hard. But why are we doing all of this, right? If this is the way to do it, why can't the language do it for us? Well, let's revisit this for a minute. Public class. How many times is your class not public? Okay, get rid of the ceremony. It is public now. How is it public? You didn't say anything, it's public. You don't want it public? Say what do you want? Private? Right? Class car. And what do we want to do now? Get rid of all of that for a minute. Let's say val, year is integer, var, miles is integer. Right there. Hey, wait a second. I want year to be final. Done. I want miles to be a variable. Done. I want a getter for the year. Done. I want a getter and a setter for the miles. Done. I want a constructor for the class. Done. I know what you're thinking. Oh my God. If this is all done, what do I do with my free time? Go home. You don't have to write stupid code, right? It works. So how does it know? How do we know it works? Val car1 equals new car. Let's say year is 2013, and I want the miles to be 0. Let's start with no miles values. Look at the error. Right? It is going to give us an error. Oh, in this case, miles, of course, no colon here. Pardon me there. So run this code. He's unhappy. Why? He's like, hey, wait a minute. You didn't give me the year value. I have a constructor written for you. Better use it. Okay, 2013, and the year is 0. So I want to print out car1.miles. I want to print out car1.year. So I'm able to ask these values from him. But no, don't try to change the year. Car1.year equals 2015. That's a way to keep the car new all the time. It says, no, you can't. It is immutable, right? There's a getter but not a setter. You cannot change it. So you can see how it tells you what you can do, but very little code, you are done writing all that. And the language says, I will write those for you. You don't have to write it. Essence versus ceremony. Did you notice one more thing? Have you ever had to teach Java to anybody? Have you done that? It's okay, be great. A few of us, really good, excellent. Right. So remember the day you had to teach Java. I know that's a little hard, but remember that. You had a captive audience in front of you. And you said, I will teach Java to you. And you said, by the way, Java is a simple language. It's got to be, every book says that, right? Java is simple. And they say, is it really hard to learn Java? No, it's very simple to learn Java. And you say, you know what, why don't I teach you something simple? And your audience are like, great, let's start with something simple. How about Hello World? Yes, let's do Hello World in Java. So your students are eager to learn Java from you. You said, let's write Hello World. Immediately hand goes up. Excuse me, instructor, yes. What's public? You don't need to know that right now. Right, takes notes. And then you said, class. Excuse me, instructor, what's a class? You don't need to know that right now. Okay, great. Hello world. There's a glimmer of hope now. Yes. Until you put the curly bracket, it came diminishingly down. What is that for, right? And then you said public. And the student is very smart. Looks at the notes, I don't have to know that right now. Then you said static, and that's it, right? And the student says, is that also something I don't need to know right now? And their hopes have completely gone. How is this simple? A void, of course, who said that? That's awesome. But that comes a little later, isn't it? Right? So, what is all this? Ceremony. What is ceremony? Ceremony is what you have to do before you get to do what you really want to do. And you would say, wait a second, but the JVM says you cannot write code unless you have a main in it to start the program. Absolutely correct. But that's JVM's problem, not your problem. Java says, I will move the JVM's problem into your shoulders. Scala says, I will take care of it for you. You don't have to do what is not necessary. But what does Scala do? It writes the public static void main for you, so you don't have to be spending the time writing it. Go ahead with your question, please.
I have 3 questions, actually.
All right, go ahead with 3 questions then.
The first is, how do you use grep to find public classes?
How do you look for private and protected, and then do a -v on it? Any other question?
Where do you document your getters and setters?
Where do you document your getters and setters? Like a Java doc, you mean?
Yeah.
You could create Java docs from this as well.
But where do you do that if you're not specifying? If you're not writing the getters and setters, where do the documentation go?
So imagine for a minute your getter and setter is doing real work. Then you would write it here as well. And then you would write the documentation for it. If the getter and setter are really stupid, then the document can say, this is stupid. We don't need an effort to do that, right? So the Java doc can say, here's the getter, here's the setter, go use it. There's nothing meaningful to be derived of it. But if there is meaning to it, if you're going to put code in it, please do. And you can write getters and setters. I'm sorry, I'm not saying you will not write getters and setters. You're not writing totally unnecessary getters and setters. You're not paying the toll, right? So yeah, when you write them, you will write the documentation. If you don't write them, it's known from the context. The document generators can do that for you. Your IDEs can show that for you. So that's not a problem.
Well, but is there any way to write documentation for the getters and setters without actually writing the getters and setters?
The answer is yes.
Okay.
What's the third question?
You answered the third question in your regard.
Well, you still required to ask the third question. Just kidding. Thank you. Absolutely. So the beauty is that, yes, I'm sorry, go ahead, please.
Yeah.
Yes, sir, thank you.
What editor are you using?
I'm sorry, say that again.
What editor are you using?
What editor am I using? I'm using a very lightweight editor called TextMate. And TextMate is a wonderful editor that knows nothing. And as a result, you can do anything you want with it. And I use this to write Java code, and you will see me do exactly the same thing for Java. You will see me doing exactly the same thing for Ruby, almost anything. I run JavaScript like this. And the beauty is, what TextMate gives you is, it allows you to fire off whatever the things you would do in the shell. And whatever he runs, he can display it for you. If you're interested in knowing how to use this, I have a little blog entry for it. Just Google for tweaking TextMate for Groovy, and I show how to do that. And once you do that, you can do this for any language. This is a Mac product, but if you're interested, there is also a Windows version called e-edit text, I think. But if you Google for TextMate for Windows, you will see it. And I've actually seen people download that product and do exactly this with that on Windows, like I've done here in the Mac. Let me answer his question before.
Yeah. Speaking of honest setter and getter question,
Yeah.
What is the Java doc for setters and getters look like in Scala?
So the first thing is the getters and setters are not like the Java's
Right.
getter and setter, right?
Right.
So this will be just a word. The variable name becomes the method name that you're calling on the site to get it. And of course, if you really want the Java style getter and setter, they punish you to write it, but you can write it by using an annotation called Java bean annotation, and then you can write it. There was another question here.
No, it was edit plus for Windows. I use edit plus.
You could do that too. Does it do similar things with it?
Yeah, you can map keys for certain external commands.
There you go. So, and it's called e-edit text?
Edit plus.
Edit plus, okay. There was another question I thought, or a comment here. Please.
Yeah, just wanted to, I guess, have you reiterate. So every class that you write in Scala has a main method. by the
No, I'm sorry, no. So the question is, does every class you write in Scala have a main method? The answer is no. What I've done here is, I have written a file, just a file. And I'm running this file with the Scala command. So when you run this, there are two options on your hand. So let's step back for a second. If you write a Java source code, what are your options? You first run javac, produce the bytecode, then you run Java. That's your only option, right? Now, with me? Okay, so, but in the case of Scala, you got two options. You can do Scala C and produce the bytecode, and then you can say Java on it and run that bytecode. You no longer have to run Scala, because you use Scala C to get the bytecode. That's one option. The other option is, you bypass the Scala C option and simply run Scala on it. This is kind of like the ability to run Java on the source code, which we cannot, right? When you run Scala on a source code, Scala takes all the source code you provide to him and then creates a main for that. And then compiles it into bytecode, runs that for you using Java, shows you the result. So that Scala is like a, what do you call it? It's like a facade or a wrapper tool that does all that work for you. Yeah. So not every file has a main, no. It is inserted when it's needed, not otherwise.
Okay.
Excellent. So we looked at how several things are optional in Scala. We saw that already. What are optional? Semicolons are optional. How many of you love semicolons? There's always this one person over there, right? and there's another person here in the front as well. Well, I have a proof that semicolons are evil. Just take a look at your hands for a second. There's a reason why your pinky is short. Because it's taken years of emotional abuse. You are typing all useful code, and then you go semicolon on it. And it says, why me? Why am I only hitting the semicolon all the time, right? So when you program in Scala, it begins to shine a little bit actually, right? Because that doesn't add values. You don't have to put semicolons. Return is optional. You don't have to say return. Return happens at the end of the function. Last expression is return. You don't have to write classes. Classes are optional. We saw that already, right? You can just throw in some code and it wraps a main around it for you. So you don't have to write classes. So a lot of these things are optional. We're not wasting time writing them. But now we can go off and do some really fun things with it, with this kind of capability of the language. I already showed you the cute classes, so I will bypass that. But I'll talk about tail recursion here. And then I want to show you a couple of interesting things you can do with this. The first thing I want to show you is recursion. We all have, recursions are cool, right? Anybody here who doesn't like recursions? Recursions are awesome. You always impress friends with recursion, right? They want to hang out with you because you can solve problems using solution to problems, How cool that is, right? So they want to hang out with you. When I learned recursion, I ran out on the street and ran in the rain. And I was like happy, this was like awesome. How did you not know this, right? That's what I was telling myself. But then I went back to school the next day, I was sharing this idea, and my professor came to me and said, what are you doing? I said, this is cool, I learned recursion, and he gave me a little slap and said, bad boy, sit in the corner, don't do it. Now, you know how sad the day is when you realize it. There's something as beautiful as recursion, you cannot use it. But why? That's right, stack overflow exception. When the input size is large, you blow up the stack. That was a sad day in my life. I went back and said, you know what, this is so beautiful, yet I cannot reach it. Right, I cannot use it. How bad is it? So let's look at an example. Factorial is a function I want to create. And this function takes a number, let's say integer. And what do I want to do in this function? Let's take a look at an example of just using a simple recursion to do this, right? So, well, actually, let's use the iteration. Var, let's say fact equals 1. I want to return the fact, but I want to say over here for all the numbers I in 1 to n. So I'm just asking him to run these numbers. Fact times equals I. Let's see if this works. So factorial of, let's say I want to say 5, right? So this is saying, find the factorial of 5, it says it's 120, right? Seems like it's right. But this is pure iteration. We created a value, imperative style, mutated it, right? Nothing special. But recursions are cool. How do we write a recursion? Let's change this. We will say if n is equal to 1, return 1. Otherwise, what do I want to do? Else, return factorial of n, so n times, right? So first value is n, times factorial of n minus 1. How does this work now? Well, in this case, Scala says, you know what, you're doing recursion, I need your help, tell me what type things are. So you have to put a type information in this particular case. So now you can see it did work, right? But what if I come over here and try some very large number? Well, it didn't quite in this case, but it should. Because I got a lot of memory apparently. Now let's say, really, let's push him a little further and see what happens, right? Okay, I have a lot of memory. Even more. Okay, there you go. So it eventually blows up, right? Depends on how much memory you have. What do we do about this? Well, it turns out there is a way to solve this problem. The problem here is, look at line number 5. What's the last operation we perform on line number 5? That's correct, it's multiplication. So we are saying, I'm going to hold the value of n on my hand, and I want to wait until factorial of n minus 1 returns, so I'm going to climb up the stack. On that level of stack, you hold n minus 1 on your hand, and climb up the stack one more time to get n minus 2's value. Eventually you blow up the stack when the value of n is high. There's a fantastic book out there called SICP, which stands for Structure and Interpretation of Computer Programs, by Sussman and Sussman. And this book talks about something very intriguing. They say we can look at a process versus a procedure. A procedure is the code we write, and a process is the code that runs. Now let's kind of understand what that means really. The code we write is not the code that runs. We know that already, right? Why so? We write the code, that's a procedure, it gets compiled into Java bytecode, then it goes to the JIT compiler, which optimizes the code, and that eventually runs. So there's a bit of a transformation that happens from the time we write the code to how it actually runs. And the JIT can eliminate code, bring in other code, do whatever, reorder code, all those optimization it can do already, right? So these guys say, look at a procedure and look at a process, they say. First we wrote an iteration, right? So iterative procedure, we wrote an iteration. No surprise there, it runs as an iterative process. You wrote iteration, it runs iteration. Second time, we wrote a recursion, so it's recursive, and what did it do? It ran recursive, at least when it could, until it blew up the stack. But the real benefit comes in when we can write it recursive, but when it runs, it becomes iterative. How cool that would be. That's like finding this magic pill And once you take it, you can eat all you want to eat and never add to the midsection. If you find that, let me know. I definitely need it. For the amount of travel I make, it's really a conflict. There's so much good food out there when I travel, and yet it becomes a problem, right? With back pain afterwards, because I can't really put on too much weight in the front. So that becomes really a very effective way to say, don't worry about how you write this, it'll be optimized when you run it. How can we do that? That is where something called TCO, or tail call optimization, comes in. Tail call optimization very quietly converts a recursion into a simple iteration under the covers. So it'll quietly turn into a while loop of some kind under the covers. How would this look like? Well, the first rule of thumb for tail recursion is the last operation must be a call to the recursion itself. Now we know what the last operation here is. It's a multiply. That's a no-no. The last operation should be the call to the method itself. How can we do that? It turns out it's very simple to do. Rather than waiting for the result to come back to do work, you tag along a partial result as the parameter to the function. It's kind of like you go to the doctor's office, they say, fill up all this paper, and then they give it to you and say, take this paper with you, go see the doc. When you're done, leave this at the front door and leave, don't come back here. So in other words, not that they don't want to see you or anything, but they just say, here, take this with you. You're tagging along the result, and then saying, go off, right? So let's see how we can do that. So here is a factorial that took a number. I'm going to say a fact, and I'm going to send a number, and in this case I'm going to send a big int, because we know for large values it's not going to be fun using an int. So I'm giving him a big int, and what's he going to do with this? He says the result of this is going to be a big int as well, isn't it? So now he says, given all these numbers, I want to start with the small number 1 and 5. 1 is the initial factorial value, and n is 5. But how is he going to do the job? So he says, if n is, the number given to me is a 1, what do I return in this case? The factorial itself, right? Else what do I do? Call factorial, take the fact times n, and send n minus 1. Notice cleverly we passed along a parameter to him with the partial result of it, right? So if we run this code now, he says the result is 120. But let's go push the limits now. So we said 20,000 last time when it blew up the stack, isn't it? So if I go back and run this now, it's running all right. Don't try to memorize that number, but that is the factorial for 20,000. You can see it didn't blow up the stack. Pretty powerful, isn't it? So what really happened? It quietly took this code and converted it into a recursion. Well, there's a good news and a bad news. Good news is we got a tail recursion. The bad news is you're happy with this design, you worked really hard, you go home, and I come along in the name of refactoring, I make some change, and what happened? It no longer is tail recursive, right? And if I run this code, it'll blow up. But the point is, do we run this code? This means you have to write a unit test for that. But there's also a challenge for it. You may run the unit test, everything works fine, then I put more memory on the machine, it becomes tricky, right? You saw me push up the number and it didn't fail for a large number. As much as I love unit testing, don't get me wrong, if there's something that can be solved by the compiler, why not? Especially in a statically typed language with a good compiler support. So notice what I'm going to do. I go up here and say Scala dot annotation dot tail rec. So if I run this code, it says, what are you talking about, right? So cannot optimize tail rec. Why? Because this is not tail call optimized. So if I remove this part now, you can see that he is happy with it because that code is tail recursive. So this compiler check can say, I'm going to analyze the code, and if I smell this and find that this is not tail call recursive, I'll yell and scream at you at compile time. So far so good? Okay, but we gained some, but we lost some. What did we lose? Yeah, he doesn't like the 1. And you have somebody who comes and says, interesting, what if I put a -1? There's always this one guy, right, who tries that, or the gal in your team. So what do you do about this? Well, okay, it would be nice if we don't have to provide this. So at the least what we could do is we could write a factorial method which takes an integer, returns a big integer, and within this function we can call the factorial with the 1 and n and simply return it. And in this case, of course, we could simply call this new version here. So we could simply call this one right here, isn't it? Good news and bad news again. Good news, we can use this version. Bad news, one of your colleagues still goes back to use it and messes up things. So how do you remove this from their eyes? What do you do in Java to make things kind of inaccessible? Make it private. Now we say, aha, that means we have to create a class and make it private, don't we? Okay, what we want to do is not make it private. What we want to do is we want to encapsulate it. That's correct. So why not simply move this function right within this function itself? This again is a higher order function. Earlier we saw how we can pass a function to a function. Now we are creating a function within a function. Now if you try to access this from here, it'll give us a slap in the hand and say, I don't know what you're talking about, what's that method that you're calling, right? So we encapsulated that fairly well in this case. We cannot call that anymore. So far so good? So we looked at tail call optimization. I already talked about classes. Scala is purely object-oriented. So what does it mean, purely object-oriented? It doesn't have static methods. No, don't leave the room yet. It actually has something better. Now, why are static methods such a bad idea? Well, remember what we learned in object-oriented programming. Separation of concern. Great idea. What does that mean? Don't mix up stuff. Awesome. And then we sit down to write Java code, what do? We write instance methods and static methods. Instance variables, static variables. What is that? Not separation of concern, right? So Scala says, let class deal with instance, period. Hey, what about stuff that don't belong to the instance, but belongs to this abstraction to the class itself? Let's create that as a singleton. Ah, that pattern, singleton. Remember that pattern? Singleton is a pattern that takes 5 minutes to learn and lifetime to get it right. Because there are so many ways to get it messed up, right? You write singleton, what does singleton say? All right, public class, write the singleton. Oh, you don't want creating instances. So you make the constructor private. You write a public method, static method. And you go home and your colleague sits there with 3 objects on his hand. How did you do that? I used reflection. Darn it. Then you go put a little bit of code there to say, no use of reflection, I won't let you do that. 3 days later, he's got 5 objects on his hand. How did you do that? Oh, I serialized and deserialized it. You put a little bit more code there. There's a pattern for this name. It's called Scotch tape driven development. You keep putting a little bit more tape on it, right? Does it work now? Put more tape on it now, right? In fact, it is so bad, Java figured a way to solve singletons. So today, what is the best way to create a singleton in Java? Kind of scary, isn't it? You would have to create an enum to make it static. Is it a pattern or anti-pattern? Kind of go figure, right? But that's effective because enum did limit the instances, so it seems to work. Let's do it. Well, it turns out singletons are so scary and hard to implement, why not the language take care of it? And the language says, I will implement it, I will make sure this is created at the class loader level. How do we do this? This is where the singletons come in. So if I have a class called car, for example, and the car basically in this case, let's say it contains simply the year and the miles, right? So I'm going to say val year is an integer, and let's say the miles is going to be a variable, let's say integer also. Now I say object, I can say car factory. Notice I use the word object. Object is a singleton. But in Scala, not only can I create a singleton like this, but my singleton can have the same name as the class also. This becomes what's called a companion object. And companion object has all the access to the object it is companion for. So within this I can say, for example, define create. And the create can say year is an integer. And here I can simply say new car given year and the miles is 0. So I could simply say over here car1 equals car.create. And in this case, I could say 2013. Now I can print out car1.year and print out let's say car1.miles. And let's say, just for our purpose, let's say 10, just so we can see it, right? So in this case, we can see the miles is 10. Even though we did not give the miles, it was created because the factory did the job for us. This is a singleton we are using. You also noticed one more thing along the way, shifting the concepts here. Notice I did not put a val in front of the year. Interesting, why is that? Let's think about this for a second. If I go back to this guy and I want to write a method called drive, it takes a distance. And I want to simply say here, miles plus equals the distance, right? Now, that code is going to increase the distance, so we could simply come back here and say car1.drive, and I could say 20 miles, and I can print out car1.miles to see if it has moved. In this case, it did. And in this case, if I come back over here and say, hey, why not distance equals some value? This is code from hell. We know we should never change variables coming into a function, right? So what do you do in Java? You say, well, you better put final over here. In Scala, you don't, because it is final. You are not allowed to modify parameters. If you compile this code, it yells at you and says, how dare you try to change your input? Bad programmer, go back to your desk and change it, right? Because that's not a good programming practice. Bugs creep in. You say, okay, Venkat, I understand that this is treated as final. Is there a way to make it non-final? The answer is yes. Go back and program in Java, right? So Scala says, no, that's not the right thing to do. I'm not going to let you do that, right? So the answer is you cannot do that. Also notice over here, a little bit of a ceremony I talked about earlier. You could remove the semicolons, you could remove the commas, you could remove the parentheses and the dots, and Scala says, why not? So you didn't have to put a dot in the drive method, you could do that as well. So talking about pure OO, static methods are segregated into a separate singleton, and that's provided as part of it. We already looked at an example of a functional style where we are passing functions to functions, right? So I'll skip the details on that part. Let's talk about two more things in the remaining time. I want to talk about traits and chaining of traits. This kind of directly hits on a design principle. Let's take an example and keep in mind along the way how you would do this in Java. And then we'll see how we don't have to do all of that, but it still works like the way it'll work in Java, right? So let's say for a minute, we'll create a class called human. So here's my class called human, and a human has a name, so name is a string. And within the human, I define a listen method. And in the listen method, I'm going to simply say print line, I'm listening, and let's say we will input the name here, right? So I'm listening. So let's go ahead and say name. So let's start with that. So we'll say Sam equals new human Sam, and let's say Sam.listen. Let's see if that works first. So it says I'm listening. So we got this implemented. But wait a minute, what is this thing called listen? Who listens, by the way?
Me.
You. I had a guy in one of the sessions. He was kind of a pretty young guy. When I asked this question, he was very eager. He immediately said, the wife? And everybody's like, really? He was made for like 3 weeks. Very young guy. So he said, you're not there yet. Right? I mean, we have this kind of a spousal selective hearing problem, isn't it? I want to be a good guy. I think I'm a good guy. But sometimes my wife talks to me. I love when she talks to me. But everything works fine until she asks me a question. This fire and forget model is good. As long as she says something, everything works fine, right? But one time she asked a question, and there's silence in the room suddenly. And I'm working away. And I kind of quietly look up and she's staring at you. So, what's your answer? And now you're like, what did she say? But she's very smart. And now she has figured out a better way to do this. She'll be talking in the room, but anytime she wants an answer, she sends me an email. I'm serious. The other day I was kind of working away. I was nodding my head for everything she says. And ping, there's an email. I'm like, okay, somebody sends me an email. And just a question from her. And I started replying. This is pathetic, right? And then that's when I realized the plot. I'm like, oh, here's the answer. So we all have selective hearing, right? We all do. But so I'll trust you. You do listen, you're saying, fine. But there is another being that listens very intently, very quietly, never speaks back to you, but listens to you. What am I talking about? Dogs. What a great animal, right? What a great pet. Dog is the best listener, right? You go home after a very tiring day, and you sit down and you say, this job sucks. And the dog kind of looks at you and says, tell me. Like kind of like a friend, right? You go to the bar and say, this job sucks. And you say, you know what, this is not just a job, but I think this is a boss that sucks. And that dog listens to you, right? Like a good friend would. So a friend listens, that's what. So you are listening, but it could be a friend who listens, right? Okay, so dog listens, but how do we work this? Here's an idea. Let's inherit a dog from a human. Dogs don't like it. So what's the Java answer to this problem? Interface. We'll create a friendable interface. How about that? Now we don't have one problem with this. We have two problems with this now. We have this friendable interface on the top. Now the human has a listen method and the dog has a listen method also, right? What if they are the same method? Now we got duplicated it. What did we do? Violate the dry principle, right? How do we solve the problem now? How do we eliminate this duplication? We could create a superclass, but the problem is dog already inherits from another class. And Java doesn't allow us to inherit from multiple classes. What would we do? Good ideas, by the way. That's a good thought process, right? That's the way we will go. What would we do now?
Use delegation.
Exactly, you use delegation. So you create a separate friendable delegate, which will have the friend method. You have the friendable interface. A human will point to the friend delegate. Dog will point to the friend delegate. And who's going to do all of this, by the way?
You.
You and I. Absolutely, right? We will have to sit there and code it. What's good about it? Job security. What's bad about it? After a while, we don't want that job, right? The smart ones go off and create an IDE for it, so it can vomit that code as well. So we don't have to be writing that, right? Well, the point really is, if that is a design approach, why can't the language do it? That's exactly what Scala does. Let's see how it does. So what I'm going to do is take this listen method away from the human. Take one step at a time. And I'm going to go up here and say, trait friend. And in this case, I'm going to put the listen method here in the friend trait. Then I come down here and say, extends friend. That's all the refactoring I did, right? Oh, by the way, I forgot one thing. A friend has a val name, which is a string, but whose value has not been assigned. It can have a name, but doesn't have a name yet. And we give a name in the derived class, right? So we moved it into a trait, wrote a human. Life is good so far? Let's take the next step. I have a class called animal. Animal has a name as well in this case. And now I have a class called dog, which overrides the name. So override val name. Override is required in this context. Extends from animal. And now what do? I say buddy equals new dog, buddy. And I say buddy dot listen. Oh, that didn't work. Why not? Because the dog is not a friend yet. Let's go back here and say with friend, and we mixed that in. So it's a compile time mix in. So far so good? So notice what we did. We created a friendable. So what is a trait? A trait is an interface. Along with the delegate abstract class, it's a buy one get one free offer. right? It created an interface and created this delegate for you. And when you mix it into a class, it inherits from the interface and delegates to the class automatically, so you don't have to write that code. Please.
So can the dog override the behavior of listen?
Absolutely.
Maybe just say whoop?
Yes, you can. And we will get to that in a few minutes with a slight different example as well. We will do that. Great question. But yes, please.
Okay, so for the dog, or for the human, right? If you don't call it as a name, but you call it something else, is it a compilation error?
Correct. So the question is, if I don't put this as a name, is it a compilation error? In this case, it is. But if that is a problem for you, don't worry about it. Give a different name for this, but whatever name you give here, just implement that method here. All that you do is you're conforming to an interface, isn't it? So if an interface has a method name and you don't like that name, you can write your own name and implement that method and route to the other method, right? So you can always get around it. You're fulfilling a contract. Either you fulfill the contract directly or you fulfill indirectly by overwriting that method. You can do that too. So far so good. Now let's say one more example. Class cat has a name and overrides the name as well here, so override, and extends from animal, which is a name. So let's say Alf equals new cat. And I'm going to say alf.listen. Will that work?
No.
No. That's because cats are not friends, right? In fact, you go home after a tiring day, the cat looks at you and says, why don't you leave some food and go back to work? Right? Anybody has a cat here? Is your cat friendly?
Mine is.
That's not been my experience. Are you sure? Would you share your cat's name with us?
Loki.
Yeah, that cat.
Loki. And what? Not Venkat. Venkat. And what's your name, sir? I'm sorry.
Robert.
Robin?
Robert.
Pardon me, I can't hear you.
Robert.
Robert. And okay, well, I'll get you a cat's name in a few minutes. All right. I'm not promising anything here, Robert, but I'll try. Well, what about Alf? Alf is a lost cause. Let's not go near Alf, right? Stay away from him. So spell your cat's name for me.
Loki.
Loki, of course. With a name like that. Equals new cat. Robert's Loki. Loki.listen. After all, Robert says Loki is friendly. Sorry, Robert, we tried. Hey, but I got one more thing. Let me try this. So we'll go back and say with friend, just for you, because you're such a nice guy standing there, and you said Loki is friendly. So we'll try this, just for you. So what did we do? Anybody else has a cat? Don't push it. All right. So all cats are evil except Loki. Robert, confirm this for me. Would you say Loki is one of his kind?
Pretty much.
There you go. So that's exactly what this is. It's exactly one of its kind. It is an anonymous inner class derived from cat, mixed in with friend. This is not a cat. This is a specialized cat. Mixed with friendliness in it. Only for Robert. So not only can you mix in traits at class level, you can mix in traits at instance level as well. Go ahead, please.
So what would be the type of Loki?
It's one of its kind. With a few dollars attached to it. If you look in the disk, it's anonymous inner class being derived from it. Just like we would hand toss anonymous inner classes in Java, right? It's an anonymous inner class.
I just was thinking that the anonymous inner classes could make things awfully tricky to debug at times, couldn't they?
Oh, I'm sorry, I don't write code with bugs, so I don't know. Yes, it could. Yeah, there are prices to pay. We have to be careful with it. You're right, but that's only a tip of the iceberg. Imagine I create one of these guys in every function. Now you got an explosion of anonymous inner classes. So we got to be careful with it as well. You're absolutely right. Please.
So Curtail on his question, Loki can be described as a friend.
Ask Robert, why are you asking me? Yes, Loki can be described as a friend. And we did, by the way. So you're right. So I can pass Loki to where a cat is being expected. I can pass Loki to where a friend is being expected. Because it implements the cat, extends the cat and implements the friend. And mixes in the friend abstract delegate. So your answer is correct. Your observation is correct. So far so good? Now, this kind of is a little bothersome. Can I take another 10 minutes? Is that okay? All right. So this kind of leads us to a bit of a bothersome thing, right? If we're bringing these guys in, what's going to happen if we start using multiple traits? How many of you have used multiple inheritance in C++? Quite a few hands going up. And those who raised the hand, how many of you want to go do more of that tonight? Not a single person. Did you see that? That's because multiple inheritance is like a gorilla. It's cute when you see it, but don't bring it home, right? It can cause havoc. And well, okay, to be fair, this is a problem with multiple inheritance in C++, not a problem in multiple inheritance itself. So what if these methods get together and say, we will not collide with each other, but instead we would cooperate with each other? Then multiple inheritance is not painful, isn't it? So what we're going to do is, we're going to bring traits together, and rather than colliding and making a mess, they will chain on each other. And when you call a method, it would call the one to its left. So I have to always turn around to say this. So it goes from right to left, by the way. So you call the method, it will hop around the methods as it goes down. Let's see how that will look like. So to understand this, let's create an abstract class called writer. And this writer class, what does the writer do? The writer writes stuff. Excellent. So define a write method. It takes a message, which is a string, and it doesn't do a whole lot. It's abstract, right? So let's leave it. But I can have different types of writers. I can have a string writer, a stream writer, a file writer, an encrypted writer, a compressed writer, what have you, right? So I can have 20 writers. Let's take one. So I have a class called the string writer. And what does a string writer do? Extends from writer and define the write method. And the write method simply says, take the string and write it. So where is it going to write it to? Well, it is going to write it to a target. Target.append the message. Well, what is this target? So target is going to be a new string, let's call it builder, right? So I've got a string builder, and I'm going to dump this into the string builder. Now, how would I use this? So define override, define toString, and this simply says target.toString. I'm going to just return the string from the string writer. So far so good, right? We could create other writers, but we will kind of skip them. How would I use this now? Write stuff. And I'm going to send a writer to him. So writer. And what's he going to write? Well, he's going to write an important message. So he's going to say writer.write. This is stupid. And then he says output writer. Let's take this for a ride and see how it works. So write stuff, new string writer. So right there it wrote, this is stupid. So far so good? Okay, what did we do? We wrote a writer, we wrote a string writer, extended from the writer. This is all plain Java stuff at this point, right? Nothing really new here. And then we simply write this. You say, all right, this is good, but as usual, our requirements change on us. Now they want not only to write the stuff, sometimes they want to write the stuff in all uppercase. I need a to uppercase method. Where would I write it? Here's an idea. Why don't we write that in the writer? What do you think?
You have to create another interface.
Well, it's going to pollute this abstract base class, right? You come back from a vacation, there's 20 methods in here. Let's carry, how did that happen? Okay, drop that idea. I can write that in the string writer. What do you think? No, duplication, because I got 20 other writers waiting for me, right? So we could use a trait for that. Let's try a trait for it. So notice what I'm going to do now. A trait called uppercase filter is the trait. And what does the uppercase filter does? It extends from writer. By the way, this word extends doesn't mean extends. It says, I want you to mix this into anything that extends from a writer. So read this as a constraint you are placing on it. Now then you say, define a write method, which takes a message. And what do I want to do in this method? I want to take the message and do uppercase, right? But now that I've taken this and converted to uppercase, I got to write it somewhere. Where do I write it? Into the guy next to you, in the chain, in the train. How do I get to the next guy? Well, whoever the next guy is, I want to call a write on him. But who is he? So we got to have a way to refer to this other guy next to us in the chain. So they said, we could use the word super. This word super doesn't mean super. In Java, super means go up the chain, right? In this context, super means go horizontally from left to right. Making sense? Now, you could say, why couldn't they use a different keyword? Well, then it would be meaningful. You would understand it. In programming, we don't do such stuff. No, I'm just kidding. Only partly. So, basically the point is, this is kind of a bit confusing. But if you thought that was confusing, wait until the next thing I show you. You are writing the write method, right? Where did that come from? It's not just a random method. That's a method that's in the writer. What do you normally have to say in a good programming practice? That's what you really meant.
Override.
Override, you're right. Override. So override. But there's a problem. Not only are you overriding the write method, but you also rely on something else. What is that? That this guy has that method, isn't it? How do you say in Java that your class has a method, but the other class which is going to work with you better have that too? The word abstract, right? So throw that in also. Isn't that beautiful? Don't talk more about it. So now, we kind of brought those together. How to use it? Write stuff, new string writer with uppercase filter. Now we are combining those two guys. How did this work? You first send the request, uppercase filter received the request, converted to uppercase, and sent it to the next guy in the chain. He took it and wrote it to the target. Make sense? One more step, two more steps. Well, I learned this recently, and this is very heartbreaking. I found out that I'm the bad guy at my house. Apparently, I go around to places like this, and I picked up a few bad words, I'm told. The other day, I was sitting down on the couch, talking to my children, and suddenly my little boy runs to my wife and says, "Mommy, Daddy is a bad boy." And then there's a little conversation in the kitchen. And then my wife comes over. This is the punishing stage, right? Comes over and says, "Did you say bad words to the children?" I said, "Why would I say bad words?" And she leaned over and said, "Did you say the S word?" I said, "That's nonsense. I would not say that S word." And I whispered to her, "It's like, not that S word." "Did you say stupid?" I said, "Of course I said stupid. You're saying it again." I said, "What's wrong with saying stupid?" "You're saying it again." I said, "Okay, what's wrong with saying that S word?" And she said, "Look, I'm raising the children to be well-mannered. They should not say things are stupid. They got to know, they got to be sensitive." And I had to put my head down and say, "Sorry, ma'am. I will not say the S word again." Does that happen to you also? That's, I've got to kind of be careful what I speak in front of the children these days. So we need a filter for it. So I'm going to create a filter. Trait. Profanity filter. Extends from writer. And what does this do? It says abstract, override, define write, and this says take a message and give me a string back to this guy, write it down, super.write, and what do? Message.replace. What? The word stupid with the word. All right? So now, write stuff, new string writer with profanity filter. Sounds reasonable? And then everything is in harmony at house right these days. Now let me try this one more time. Write stuff, new string writer with uppercase filter. You know where I'm going with this? With profanity filter. We combine them together, run it. I heard that. I heard the wow, right? Scala is awesome in that regard, right? In spite of the little criticisms I make from time to time with few things in it. So it sends the request to profanity filter, it strips that word out, and then sends it to the uppercase filter, which transforms to uppercase, sends it to the target, writes it down. You probably already guessed the problem with this. Go ahead, please.
If you do it the other way around.
There you go. So let's see what happens. And as a very observant person, he said, you know what, if I say profanity filter with uppercase filter, because the sequencing matters, and because I wrote this in a certain way, it sends it here, converts to all uppercase, sends it to my profanity filter, which only looks for lowercase, and as a result, the code leaves out the word, this is stupid. But there is some good news in it. The other day I was home, and something really went wrong. And I said, this is stupid! And immediately my little kid's eyes widened. And he said, Mommy. And my wife said, Daddy is upset right now, be quiet. So this fits the domain really well, by the way. That's all I have, folks. Thank you.